Alright, let's take a look at what's actually two different questions on your homework, but it's the exact same question with different numbers, so I'm just going to work it once for you. This is numbers 13 and 16, and this is the court reporting question. What they're giving us is a derivative here. This is n prime of t, which is the number of words per minute. Number of words per minute. It's a rate that students have after t weeks in a court reporting course. So they're saying that their words per minute are reflected by this function, that if you plugged in a 1, it would tell you the rate of change, how much faster they're typing or doing their court reporting or whatever it is they're doing, transcribing, dictation, something like that. Whatever their rate of change is after that many weeks. So, you know, after 4 weeks, you'd plug in a 4. After 10 weeks, you'd plug in a 10. At the beginning of it, before it started, you would plug in a 0, which is going to come in handy later. But right now, what they're asking us to do, giving us this derivative, is they're asking us to find n of t. Okay? Well, if they have a derivative and they want us to go back to the original function, what we need to do is take an integral. So let's take an integral of what they gave us. So the integral of 2e to the negative 0.02t dt. I don't know how to take that integral. That's not something that we've learned in the past. There are no rules for taking e to some power that's a function in and of itself. But what I do know how to do is take the integral of e to the u du, right? The integral of e to the u is just going to be e to the u. I can do that. So let's see if we can manage to rewrite this function in terms of something we know how to do. Well, I said I can do e to the u, so my u is going to have to be whatever this exponent was, right? Because I'm saying e to the u, so e to the u, I want that to be my u. So that's going to be negative 0.02t. So if I take the derivative of that, that's the derivative of u with respect to t, because that's my variable, that is going to give me negative 0.02. If I rewrite that, du equals negative 0.02 dt. I just brought over my dt. See the dt here? Brought it over here. Okay, does that match up with what I've got up here? Not exactly, but it's not the end of the world. If you find yourself in a position where you've got something extra in your function and or something extra in your du that doesn't quite match up, if there's anything extra in your function, it goes into the numerator outside of your integral. If there's anything extra in your du, it goes into the denominator outside your function. So I'm bringing down this is going here, this is going there, okay? And my dt I can check off because that's already there. But because I had not quite the right amount of e to the u's, well, I have 2 divided by negative 0.02 of the amount of e to the u's that I needed. And actually, if we rewrite that, that turns into a negative 100. You can plug that into your calculator, times the integral of e to the u du. Well, like we said, we know this this integral, so that's negative 100 times e to the u plus c. Sorry, I had my constant of integration there. And now I can just plug in what I found for u earlier. So that's negative 100 times e to the negative 0.02t plus c. So that's my n of t. So that's n of t equals this here function. This 100, negative 100 times e to the negative 0.02 plus c. But they want the exact function. And the only way we're going to find the exact function is with more information. But what they tell us in this word problem is that the average student enrolled in the course begins with a dictation speed of 60 words per minute. Now remember that we're measuring time in weeks and that it's t weeks after the beginning of the course. So the beginning of the course, t is going to equal 0. So what they're telling us is that n of t well, actually n of 0, we're filling in a 0 for the t, equals 60. That when the time is 0 at the beginning of the course, that function should equal 60, because that's how quickly the students are able to dictate. Okay? So if n of 0 equals 60, and this is n of t, well, I can just plug in zeros for my t's and set this equal to 60, and then I'll be able to solve for c to fill in this blank, because I don't know what this is yet. Okay? So negative 100 times e to the negative 0.02 times 0. Okay, I'm plugging that in, plus c equals 60. Well, e to the 0 is just going to be 1, so that gives me negative 100 plus c equals 60. Sorry. So c equals 160. That means I can plug that 160 in where I had c before, so my final function, the one that I want to enter into WebAssign, is going to be n of t, that's what they're looking for, equals negative 100 times e to the negative 0.02t plus 160. And that is what you're going to enter. So let's go over the steps again, because this was a pretty drawn out process. We started with a derivative that they gave us, and they wanted us to go from the derivative to the original function. That meant we had to take an integral. But to take the integral, we needed to rewrite it in terms of u. So there's nothing that we could solve here, but if we could rewrite it in terms of e to the u du, then we were going to be golden. So we do that. We write e to the u du. We let u be our exponent, and we come over here. If u was the exponent, then the derivative of that was negative 0.02. Rewrite that as du equals negative 0.02 dt. Now we have to go back and check to see whether or not we got all of the pieces of our original function in here. So I've got e to the u, well, that's this part here. Du should be negative 0.02 dt. Well, I've got the dt, but I've got more than I need up here. All right? So what I do when I have extra inside that integral, I bring that extra piece out and put it into the numerator. If I have extra inside my du, I bring that out and put it into the denominator outside of my integral. So now I have 2 divided by negative 0.02 times the integral of e to the u du. I simplified that in my calculator. That gave me negative 100 times the integral of e to the u du. I know that the integral of e to the u du is just e to the u plus c, so that left me with negative 100 e to the u plus c. I filled back in what I found for u up here. This was the u that I chose, so I plugged that right back in. So my function n of t is negative 100 e to the negative 0.02t plus c. But that's not good enough. They want us to figure out what c is. They've told us that n of 0 equals 60, so we are then able to plug in zeros for our t's and set that equal to 60. When we solve for c, we find out that c actually equals 160. So now we can plug that 160 back in for our c, giving us our final answer, negative 100 e to the negative 0.02t plus 160.